In this lesson, I'll show you how to shift and reflect a square root function using transformations. Just a few notes before we get started. There are two types of reflections. One that is about the x-axis, and that's when you have a negative value being multiplied to the function. And another one known as a reflection about the y-axis, and that's when the input is negative. When it comes to horizontal shifts, we look at what's being added or subtracted to the input, and that's summarized right here. Now, if that's difficult to understand, let's take a look at an example where we break this down even further. Take, for example, in question number 1. Starting with the function f of x is equal to the square root of x, construct the graph f of x is equal to negative square root, and within the square root we have negative x plus 5. To tackle these problems, we need to look at a general format of a square root function. The general format always looks like this, where you have a value at the front, which we call a, and that's a constant, and it's being multiplied to the square root of, on the inside, being k bracket x minus d, k being the level of horizontal compression or stretch, and d being the horizontal translation which we're concerned about, plus c, which represents the vertical translation, and in this video we're not concerned about c at all. Now look at our function. Our function has an a value that is negative. If the a value is negative, that is a reflection about the x-axis. Before I explain to you the significance of that, let's look at some key anchor points along this curve. So I'll make a quick xy table like this, and one key anchor point is at 0 and 0, another one is at 4 and 2, and a third one can be at 9 and 3. Now generally you only need 2 anchor points to figure out the new curve, but we'll be using 3 for this exercise. Now when you have a reflection about the x-axis, all the x values remain the same, and the y outputs, or the y values, their symbol flips. So if it's positive it becomes a negative, and if it's negative it becomes positive. Therefore our brand new table, taking into account only the fact that we have a negative out here, will be the following values: 0, 4, 9, those haven't changed, and the symbols here will change. So positive 2 becomes negative 2, and 3 becomes negative 3. The next two things that I will look at are the values of k and d. Now notice that we have negative x plus 5 within this radical, within the square root. What I will do is factor out a negative from both of these terms. So I end up with negative 1 bracket x minus 5. And I'm doing this so that I can model the standard form of a square root function. As you can see from here, the k value is negative 1. And when the k value is negative, we have a reflection about the y-axis. When you have a reflection about the y-axis, you keep the y outputs the same. So we'll keep these the way they are, 0, negative 2, and negative 3. But the x inputs will have their symbols changed. So we go from positive 4 to negative 4, positive 9 to negative 9, and these are our 3 points. And finally, for our last change, we will look at this value. Notice that this value is negative 5. If that value is negative, then you horizontally translate to the right. If it's positive, you horizontally translate to the left that many units. So in our case, it is minus 5, so it's a horizontal translation to the right. And what this means is that all of these x values will be adding 5 to them. So you keep the y's the way they are, and adding 5 to 0 makes 5, adding 5 to negative 4 makes positive 1, and adding 5 to negative 9 makes negative 4. Okay, if we plot these points, then we have our new graph. Let's start with 5 and 0. 5 and 0 is right here. The next point is 1 and negative 2, so positive 1 and negative 2. And our last point is negative 4 and negative 3. Negative 4 and negative 3. If we connect these, we get the following. Alright, in question number 2, we have a very similar situation. So rather than having me show you how to do this, I want you to take the opportunity to do it on your own And if you still need help, feel free to leave a comment in the comment section below and I will gladly upload the solution for this question as well. Thank you for watching.